you put the value of L here, and so this in general you can write as Qi Pi dot minus L. Okay? And here eliminate all velocities. This is the standard procedure. Always eliminate all the velocities. Only Q's and P's are there. So only Q's and P's are there. Because Hamiltonian by definition is a function of Q's and P's. L is a function of Qi dot. But no P's. There are no P's there. So here you have Q's and P's. Any space spanned by the coordinates and the momentum like Q's and P's is called as the phase space. These are called as the phase space variables. So H depends only on Q's and P's. Okay? And in this particular case, you can easily, this will come out to be, let me write here, H equal to 1/2 Px square, or let me put Px square by 2m plus 1/2. Now, the result is not surprising. It's a sum of kinetic and potential energy. So it's the total energy of the system. One could talk a lot on this, but I would just mention that this thing holds true for conservative systems, but the procedure that you have followed holds true for all kind of systems, conservative, non-conservative, all systems. So in general, we must adopt this procedure. And in this, you have never to worry that you are going to miss something or you are going to make mistakes. No, because this takes care of everything. It is the most general definition of a Hamiltonian. Fine. So then you also define the Poisson bracket of X and P, calculate it using the standard procedure, and this would come out to be 1. And if you use Dirac quantization rule, which says that PV corresponds to minus iota by h cross times substitution relation, you immediately find that x Px is equal to your this is iota times h cross times the Poisson, which is 1, so iota h cross. If you like to write it in terms of Qi Pi, then you put your delta Ij. Okay? This is how whatever you keep learning, you also start making use of it. So Qi Pi you can write as this. If it's Qi x P by, then this would be, they would be different, it would be 0. But x Px would be 1. Because delta 1 is 1. Very good. So now it seems we are ready to, this was essentially so far a recap of things that we already somehow had covered. Now we go a little bit further. Alright, so I make a space on my green board. I was so much used to calling it blackboard, but I modified myself because Dharma has been kind to provide us a green board. So I no longer use the word blackboard. By mistake I could, but because that one has spoken for years. But now we have this green board, and in some of the lecture rooms, I I'm not so sure if we everywhere have green board. Because some of the blackboards are lying so in such a nice fashion that one doesn't like to change them. And they are quite good. But of course, my most favorite lecture room there is so-called Dsk lecture room, okay, named after Daulat Singh Kothari. And it's a still bigger board and very nice, so because the number of students is also large. So, of course, green board, and I love that. Now, let me again write let me write one-dimensional harmonic oscillator. Okay, and here now I can directly start with H. So this is P. Let me drop X subscript with the P. So P square by 2m and plus 1/2 m omega square x square. K I have replaced by m omega square for some reasons of convenience, okay? Because one can identify m with the so-called mass of the particle, and omega one can identify with the frequency, and so on. Now, so far there is nothing new, but now let me introduce x equals to h cross by 2m omega into P plus A dagger. Then P will come out to be, one can calculate, will come out to be iota times mh cross omega by 2. This is just a constant. And you know the procedure, how to get it, minus A plus A dagger. Okay? Later on, I would tell you that this really has a name in field theory as a Fock space decomposition, FOCK. Fock space Fock space decomposition of X. So here in that I would call they are now, let me first promote all the variables here to the corresponding quantum mechanical operator, so that for me now whatever is written on the board, there is no classical variable, they are all quantum mechanical variables. Okay, so the operator for x is x, for px is px, but given by minus iota h cross del over del x. Okay, so for me x and p are now operators, and therefore on the right hand side what I have has to be an operator. So this is operator A and A dagger. A is annihilation operator. That couple of names, the annihilation operator or destruction operator or some more. I will tell you as it comes to my mind. So, and this is the creation operator. After a couple of minutes, I would tell you why they are called annihilation and creation operators. Okay, and Fock is the name of a physicist, okay, or maybe a mathematician. So later on, or a couple of minutes later, I would define a number capital N, which is the product of A dagger A. Okay, and this I would call as number operator. Number operator. Okay, so in any representation in which this n is diagonal, any representation where this n is diagonal is called as a Fock space. So here you will realize that n indeed comes out to be a diagonal. So if I represent it by a matrix, I can calculate precisely its matrix elements, and so you will have non-diagonal elements would be 0, only diagonal elements would be non-zero. And so it's diagonal. Is that okay? If I write a matrix corresponding to capital N, non-diagonal elements would turn out to be 0. In the same approach, I would not assume anything anywhere extra. Whatever we assume, we must be able to prove it. Okay? Good. So, here, and of course here everything, because X and P are bosonic. So all these objects that are involved here, A and A dagger, they are all bosonic. And one can in fact prove that your A dagger is 1, A is 0, and A dagger is also 0. So, and so here, whether I say that we assume, or in fact we are not assuming, because you assume only for X and P, which I have now erased. Okay, they are called as the fundamental Poisson brackets or fundamental commutation relations in quantum mechanics. Q and P's, all those things. But in fact, if I define a Poisson bracket and I make use of that definition,